Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be doing a repair, and it's something from the 90s. It's a motherboard. Now, I don't think this box necessarily is anything to do with the motherboard that's in here. It does say free tech on it and quality series. Well, the quality wasn't quite there, because if we pop the motherboard out of the box here, what we have is a 486 motherboard with some local bus slots. So this is from the early to mid 90s era. It was donated by viewer Matt on a mail call episode, and this motherboard, like so many others, has suffered the wrath of the VARTA battery right here that has leaked and killed some traces. Well, I'm presuming that's what's happened, because in my testing I wrote doesn't post, and that would have been in the mail call episode. So let's break out the microscope and try to bodge in some traces, see if we can get this 46 motherboard working. Let's start by taking a closer look at this motherboard, and we'll actually do a test before we start doing any repair work on it. So we have a 486 processor here. It's probably a DX or something like that. I'm noticing this thing does not have a zero insertion force socket, which is a little bit disappointing. Let's try to get that heatsink off of here so we can actually look at what type of processor is on here. Since this doesn't have the normal socket as you would expect, where typically the heatsink actually clips on to the socket, that's pretty much the way it is on all modern processors now. This actually clips onto the chip itself. So if we slide that off, oh, look at what we have under there. Turn that around so the electrons don't fall out. AMD 46 DX266. Essentially fully compatible with the Intel variant of this chip. It's a 5-volt processor. It doesn't require a lower voltage like the later or higher speed AMD processors. As you can see, we have an SIS chipset of some type. Let's get this sticker off so we can uncover the exact chip used, and that way I can look up the motherboard on the retro web. We have an SIS 85C 461 chipset with a date code of 1993, 32nd week. You notice this sticker right here says Genoa, and that's a brand that made peripherals back in the day. But when you're looking up a motherboard like this, it doesn't really say what it is. All you really need to know is the chipset part. It's a 486 and the number of 8-bit, 16-bit, and local bus slots. Usually that's enough to narrow it right down. I cannot recommend the RetroWeb more. What a wonderful resource this is. Here on the website here, we put in SIS. There's the chipset 85C 461. We have 2 8-bit slots, 2 32-bit slots, and we have 6 ISA slots, 16-bit ISA slots. And I also selected socket 3, which should be the correct socket for this. And we hit search. No result. I think what I'm going to do is I'm going to reset the fields to get rid of that CPU socket here, because I bet you whoever put this motherboard in didn't consider that this pin grid array socket is not socket 3. So let's reset that. Let's put back in the chipset. I'm going to put 2 ISA slots, and let's see if this turns up more. Okay, we have a couple different motherboards, and none of them are this motherboard. Very interesting. Well, I have to say that's the first time the RetroWeb's actually not had what I was looking for in there. But of course, it's a website that has all community submissions, so I'm just going to have to submit this motherboard here, photographs of it, and a dump of the BIOS. Hopefully we can get this board working, and that way they can update their information. The reason why I was really looking at the RetroWeb, though, is I wanted to look for the jumper configuration just to validate that the CPU jumper configuration was correct. Because when I said that this thing wasn't posting in my little note there from the mail call episode, the thing is, if the CPU is not configured correctly, it may not actually execute any code from the BIOS, and that means you're not going to see any postcodes whatsoever. We need to make sure the CPU is configured, and that's one of the Achilles heels of 46 motherboards. There's no auto detect for the type of CPU that you have in the motherboard. It requires manual configuration of a whole bunch of jumpers to make sure that it's working. It's quite possible that when Matt had this motherboard, or whoever this motherboard came from before him, maybe some of the jumpers were stolen. Maybe this is not the right CPU for the board as it's configured. So we really need to do some validation just to see if this thing is configured correctly. That's really the first step you need to do when trying to troubleshoot a 46 like this. I started looking at this board very closely to see if I could find any markings that would identify a model number. I do see made in Taiwan down here. There's an assembly number right there. It doesn't really give us anything, and it says designed in the USA. And on the back of the board, nothing much to tell other than a bunch of corrosion right here from the battery leakage. Now it's down here on this part of the motherboard. We have a couple jumpers there, another one installed there, one that's off on one pin. These there look like they're installed correctly. And we have one over here for the cache memory, almost certainly. I mean, that's a good sign that there seems to be normal set of jumpers on here. If there were no jumpers installed on any of these locations, I would fear that this has lost its configuration. But because these look like they haven't necessarily been molested, let's just assume that these are in the correct spot for all of these jumpers here for this particular configuration, which is essentially the same as an Intel 486DX33. 66 megahertz means it's clock doubled, but it's done internally. So you set up your motherboard for a 33 megahertz processor to install this 46 in there, and it should work. A little Googling for Genoa 46 motherboard revealed this, but this is clearly not the right motherboard, even though it's the right number of memory slots, 3 32-bit local bus slots, while we only have 2 on this motherboard. Not to mention it has a ZIF CPU socket 3, which is not what this board has, even though this does have the same chipset. Over here on stassen.org, this also came up in my Google search result, unidentified SIS 486. Unfortunately though, with the picture, not the right board again. It has 2 72-pin sockets, and we have 3 local bus slots again. Well, here's something interesting. We have a similar looking motherboard. It's very, very similar, in fact. Although, look at this area right here, and that chip is missing right there. Compared to this motherboard here, which has that chip actually soldered onto the board, and the chipset is over here on this motherboard on Reddit, and there's like a footprint for probably a 386, or sorry, a 486SX that could be mounted directly to the motherboard. This board does look really, really similar. No damage though, except for this major change here, and then that missing chip. I'm gonna say that these boards are pretty much the same. And let's take a look at the processor that's in here. So 46DX33. Let's see if we can spy the jumper configurations. All right, and unfortunately, it looks like the jumpers are in a different orientation. They're not exactly in the same position. And this also, I just noticed, has this sort of like lever here. So it's an early zero insertion force socket. So it's like a later revision of this board, I guess. Now, there was a link in the comments there, and look, it's the FreeTech, which is what was written on that box, or Flexus 46F23. Let me take a look at the box. Maybe that's the matching box for this board, and maybe it actually has a part number on it. Well, I don't think so. Even though it's the same brand, this looks like a Pentium motherboard because there's PCI slots on here, and it looks like a Coast module there. And when we look, I saw this one sticker right here. Take a look at this, the Pelican 2 P5F85. So this would be a Pentium motherboard that was in this box. I'm assuming that someone got an upgrade at some point. They bought a Pentium board and upgraded their 46 and putting this motherboard back into the Pentium box. And in case anyone was wondering, there's no manual or anything like that in the box. Armed with that knowledge that this is a FreeTech motherboard, I just typed in FreeTech and I typed in the SIS part number 85C461, and look what came up on the retro web. Oh, this is not the same board. I thought from the thumbnail it was, because, oh, well, I don't know, just the thumbnail looks similar, but nope, nope, it's different. This has 3 slots and has that same crappy socket though, same chipset, has an extra chip right there, not to mention 72-pin memory modules. And this, my gentle viewers, is one of the problems with 46 motherboards. There were so many companies making these by the 90s. There are just ones out there that have no information. We have no documentation for them and, well, no way to really know how the jumpers are configured. And as I mentioned, that is one of the bigger problems with these motherboards is you need to configure the jumpers correctly for them to work. So with that said, let's do some basic testing. I plugged in a power supply, which is working. We have one of these post analyzer cards here. We'll just stick it into that ISA slot right there. Tilt this up so you can see what the output is on the post card. And let's turn on the power supply. Okay, so taking a look here, the reset light is on. That is this bottom one on the right. I think the CPU is not gonna run at all if that is stuck on. That reset light should be on while the system is in reset, but then it should shut off once the reset circuit releases reset and the CPU should start executing code. So we're going to use this known good working motherboard here as a test. Keep an eye specifically on that bottom right LED. And yep, see that? I'm going to push, okay, ignore the beeping. I'm going to push the reset button, so I'm holding it. Notice the light's on. As soon as I let go, the machine starts to post. So right there, we have our first problem we need to solve. This machine will never do anything while it's stuck in reset. Now, let's focus our attention to this corrosion up here that's on both the top side and the bottom side of the board. If we shuffle the board over here, take a look at this 40-pin IC. So this IC here is the keyboard controller, which obviously is going to have traces that make their way over to the keyboard connector. And I'm pretty sure that on these later motherboards that this chip has, well, a role to play in the reset of the system. Now, it's not like we have schematics for all these motherboards, especially ones like this, where we can't even find the jumper configuration for it. And really, there are no 46 motherboard schematics, at least not any that I'm aware of. But I'm pretty sure that reset circuit has to do with stuff, at least in this top area of the board here. So we really need to go ahead and try to figure out exactly which traces are bad here and repair them all. And let's see if that fixes this particular reset problem. Now, what you're looking at here is the maximum zoom on my bench camera. I can't get any closer than this. So I think we need to switch over to the microscope to get a closer look at exactly what's going on in this damaged area. Now we're looking at the back side of the board. We'll have to do the same on the other side. All right, so here is the top side of the board. Yeah, that looks, that looks pretty bad, doesn't it? If we move over here, this is where the battery was connected. Not great. Someone cut the battery away with some side cutters there, but these traces definitely worse for wear. And then over here we have the little resistor and that's some corrosion around the via there. Let's see if there's anything else floating around. Looks like we have a little bit of corrosion there, a lot of like hair or something as well. Little corrosion right there. That's probably okay. Over on the other side of the keyboard connector, things look fine. I don't see anything wrong there. Okay, having to turn the motherboard because the stand is terrible on this microscope here. We got some more corrosion there. We have a little bit bubbling up there. These two diodes have seen better days. These are almost certainly going to be for the battery. This is the external battery connector, so this will have something to do with that almost certainly. We have some problems there. And moving over, things start to look a lot better. Other than a little bit of corrosion here on this standoff hole, I think that's pretty much where it ends. There's the real-time clock crystal, 32 kilohertz. And looking at these components, it looks pretty good. There's a little bit of green right there. Okay, flipping the motherboard onto its backside, we see the sadness that is all this corrosion here. These traces are almost certainly gone. So that here is a via that's not looking so hot, but that trace right there is almost certainly no way it can carry anything. And for all I know, that's a reset signal because look, that trace goes all the way over here. All right, goes down to the ISA slots. Okay, so that's not necessarily related, but we also have vias. Oh, this all looks so bad. Heading down here and making their way down there. So, okay, well, we know what we gotta do. We really need to try to, I don't know, deal with this mess here a little bit. Now, normally I would want to use a Dremel with one of those little rubber polishing bits on there, but unfortunately, all of mine are gone. I have like wore them all away. So I've ordered some more and they're on their way, but it's going to take a while. They're coming from AliExpress. So in the meantime, we're going to use this, which is an engraver. And I found that this thing, which is like a little rotary tool with a little sharp bit on the end, works quite well for this exact type of work. Let's demonstrate here. So there's the little bit right there. And if I turn this on, it is now spinning. And you can grind away at this mess here. We're trying to expose whatever copper is actually still there, if any at all. And this is obviously going to take away some of the fiberglass as well. But if we spray this with a little IPA and we wipe here, we should be starting to see if there's any copper under there at all. And there is just a little bit. So we're just going to keep going on this. And I'm just going to try to expose this. Look at that. That is bad corrosion there. We're going to try to expose that copper entirely. And let's just see what's left of that trace. A little IPA. A little wipey. Well, you can definitely see right there that there's not going to be any conduction at all, because the copper is entirely missing in big sections there. So what I'm gonna do now is I'm gonna do a jump cut, and I'm gonna use this little tool here to grind away at all that stuff on the top and the bottom to expose everything I can, and then we'll start adding bodge wires. I decided to leave this footage in. I was gonna do a jump cut, but watching it now on playback, it's kind of like a science experiment. All that copper is so corroded, it's turned that kind of beautiful green color. But with the IPA that I sprayed on there and it mixing through, it's, well, I don't know, it looks really interesting. Now, normally when you grind on top of one of these traces, there's a lot of copper there, and I'm not pushing very hard. I'm just pushing very, very lightly. And it would only expose the top layer of the copper, and there would be plenty of copper underneath. But as you can see here, the copper is so degraded that as I touch the bit to it, it just basically disintegrates, and large sections are entirely missing. Now, I don't intend to actually use these traces because they are completely corroded and they're not going to carry any current anyways. But the idea is just to expose everything so I can see exactly where the traces go bad, and then I have to figure out where they go and then bodge over them with wires. Now, if the traces were mostly intact, you could try to re-tin them, or you could try to just bridge the little mini areas that are broken. But I'm finding here that, well, large sections of the traces are completely gone. Also, some of the traces are mostly good, but they have little black marks on them, and that's the corrosion that's just starting under the solder mask. So you want to scrape that away with the bit just to expose the fresh copper underneath, just to stop any further corrosion. Not to mention, all that corrosion that was on this board theoretically could have kept corroding, so me removing it with this bit should stop that process. All right, so this is what we're left with. It's kind of ugly, but the idea is we wanted to expose the traces. We'll get all the solder mask off the top of them so that we could see where all the damage is. And, you know, there's lots of damage. Look at that. Those traces there, there's no way they're going to conduct at all. So what we're going to need to do is let this alcohol dry. That's why it's wet looking. Parts of the board here that aren't bad, now that I've sort of got rid of most of the corrosion except for that gap right there, we need to put flux on these traces and re-tin them, and then bridge over these little gaps right here and potentially reinforce this stuff. And, you know, it's eating away a lot of the copper here. That's what that green corrosion was. So this is much thinner than it was. So probably for these thick traces, we should probably just like run new wires entirely. Now some of them like this are here, that's a break. We're gonna have to find out on the top side where that goes to, and then potentially run a bodge wire from this side of the board, like wherever this goes to, like right there, flipped over to the other side and try to figure out where that's going and then attach it there. And of course to do that, I'm gonna have to do that entire process over again, but on this side of the board, and try to reveal all of the traces that have gone bad. All right, here we are on the top side, and the traces are a mess. We got a bunch of completely eaten away traces. This trace right here that's eaten away, that doesn't matter. That comes from this diode here that goes under there, makes its way over here to this battery connection. We're not going to use that, so that doesn't matter. But this trace right here, I think that's going to the keyboard connector. It's looking pretty rough. So I'm just gonna have to do a whole lot of figuring out where these vias go on the other side, and then just jumping over entirely. So taking away some of the solder mask like right here, and then we can attach a bodge wire to the trace itself. I mean, the other possibility actually is to find out where that trace goes, but as you can see, it's under this chip here, so that's not really possible. So with that said, I'm probably gonna remove some of the solder mask on the top side here, and then we're gonna look at this via right here. Let's try to figure that via out, just as an example compared to these two diodes here. All right, so we have the battery connector here. There are the two diodes, and there's that via right there. And actually that is one that has a bad connection there. So what we need to do is figure out where this goes, like to that pin right there, and connect a bodge wire from this component either on the bottom side or on the top side to this trace right here. And I'm pretty sure it's one of these inductors that it actually connects to. So what we can do actually is figure that out and just run a bodge wire right from the top side here over to that trace. And I did some comparisons, that pin right there, and let's just make sure the multimeter is in the right mode. It is. That pin right there is what makes its way up to this via right here. And look, nothing, no continuity at all. So let me scrape away some of this solder mask on this trace right here, and I'll run a bodge wire. All right, I put a drop of flux on there. So there we go, that tinned right up without any issue. And you know what, I'm noticing down in this area here, where I'm about to put the bodge wire onto this inductor right there. Look at this resistor right here, look at that via. Not looking super good. And in fact, take a look at that trace right there. That looks broken as well. Now it's really hard for me to do without blocking the camera. So I'm just gonna try to grind that away a little bit. That is probably fine, to be honest. Maybe or maybe not. It looks thin, but I think it should be fine. Actually, you know what? That might have just taken it out entirely right there. Oh, yep, it is gone. It was so thin, a little lightest of grinding took that out. So I'm just gonna have to put some flux on there and hopefully I can tin that and bridge it across with some solder. And this, my friends, is exactly what you have to do with this type of damage. You have to look in there really carefully and then grind away any potential damage. And that's not bridging. So I'm gonna try to get this bodge wire soldered onto there. Oh, it moved. So that might be good enough there, maybe, possibly. Cut that off. Okay, so I just switched my fine point probes and I noticed that is loose, which is annoying because as soon as I put heat to it, it's gonna try to move. So I'm gonna hold it with a screwdriver there. This is really difficult to get in the right position. Okay, maybe that is gonna work now, I don't know. What I was trying to do is get the tip into the via there. And over here, I'm gonna poke through the solder mask. There we go. We have continuity now. So yeah, that is the kind of work that you have to do. And I came over here to bodge a wire between this inductor right here and that trace that we scraped some of the mask off and tinned. I'm just gonna scrape this resistor clean. It's looking a little crusty. Yeah, anyways, that's just flux there. Okay, I just tried to tin this and it didn't really work, so I'm just gonna use this grinder here just to make a clean spot right there. And now we have some nice shiny solder on there. So we'll get this bodge wire on. I'm trying not to melt things that are in proximity. You can't really see on here, but there's a slot connector next to it. We have the power connector. There's just not a lot of room. Alrighty, there's the bodge wire. It goes from that trace there. I'll do some better routing of it in a moment, but it goes down there to that. And now we should have the connectivity on that one trace that we so desire. Let's just double check. So from there over to here, this connection now is what this motherboard needed. Well, one of many of what it needed. So I've explained the methodology and now I'm gonna turn off the audio and we're gonna just do a time lapse where I'm gonna try to fix everything I can find that's not working using the same techniques here. Alrighty, I worked on this for a good number of hours. On the top side, it doesn't look too different. There are just two bodges on there. And I've tinned a couple of the traces and I haven't cleaned any of this up yet, so there's a lot of flux on the board. But if we flip the board over, that is where, well, yeah, a lot of carnage. So this red that you're seeing on here, I was using a marker. I was using this Sharpie right here to try to mark which ones I had already done the repairs on. But then I sprayed alcohol in here to kind of clean it up. There's a bunch of flux on here. But yeah, so this is the clock chip here. We have 3 going to there. There's one that goes to the keyboard controller that makes its way over here. And then there's stuff that goes down here. Now, I could have connected it to these traces up here, but I just decided to go right to the source. There's a couple vias that it's in, and one of the bodge wires is even on the CPU. So yeah, no wonder why this thing didn't work. There's a lot of stuff here that was bad. I'm not 100% sure I got everything. Oh yeah, there's a couple that went to the keyboard connector itself. Not 100% sure I got everything, but I spent a lot of time sort of going over there, marking which ones I had already done and stuff like that. So I think we can at least give this thing a try. A few observations. This pin here on the power controller, I think is the power good. That goes over here to the keyboard controller. I have a feeling that alone is going to keep the machine in reset all the time. And then this stuff over here on the keyboard would have kept that from working. And then the clock chip, I'm not sure what that has to do with anything, if that would keep the system from working. But yeah, 3 bad traces on there, definitely a problem. And incidentally, if you're wondering about this bodge that goes from there to there, seemingly no damaged area, well, this trace goes up here along the top and it wraps around. It's a very out of the way trace there. This is one of the memory slots here. So yeah, that was an interesting one. Anyhow, I'm not 100% sure I got everything perfectly, but you know what? What are we gonna lose if it doesn't work? I mean, this thing was dead already. So let's hook up the power, get the postcard in here, and let's see if we get any signs of life. Look, it's freaking posting. It is freaking posting. Wow, absolutely wow. Now, let's turn that back on again. I didn't hear a beep. Oh, there it is. That is the no memory beep. I can't believe it. This thing is gonna work. This poor motherboard, which I have scraped and ground and put bodge wires on, I think this thing is gonna work. Maybe. I mean, I shouldn't count my chickens, right? I shouldn't count my chickens. Let's get some memory in here. This memory here is tested, 1 megabyte modules. We have 4 that are the same. It says bank 0 right here on the motherboard. So that should be the bank for getting this thing sort of starting. All right, now with memory in here, we should get a different beep. It should give us the video card complaint. So here we go. Uh-oh. That to me sounds like there's still something wrong with the memory subsystem. Because I think 10, 13, I don't know. Let's plug a video card in. Let's just see if that makes any difference. We'll move this up so we can see it. Okay, let's try again. Yeah, no difference. Stuck at 13. You know, the worst thing here is that we don't know for sure if this board is configured correctly, like for the right CPU and whatnot. CPU is definitely warming up now, so that it's doing something. We don't know if it's configured correctly, and you know, maybe there's a cache problem. There could be some other issue. Look at that, me pawing around on the board. It's made the code go back to 0. Well, it is the next day, and after last night's failure, I decided to, well, take a break, so to speak. So, recap. Lots of bodge wires. Thing was posting though, so yeah, that's a good sign. But then we were getting 3 beeps and a postcode of 13. I put memory in the board, known good memory, by the way, no change. I must admit that has me very worried because obviously with the predominant amount of damage up here on the top part of the board, memory errors, well, that shouldn't really be happening. Now we did have one trace that goes from the CPU over to the memory sockets, and that just is because that trace took a roundabout way of getting towards the memory. Well, just to validate that my work was correct with that particular pin, I took a look here at the pin that I rerouted, and it's this one right here, DP3. And according to the datasheet for the processor, those are the data parity lines. And there are 4 lines because, of course, being a 32-bit processor, we have 4 8-bit banks of memory. And each one of those data parity lines makes its way to one of the 4 memory modules in each of the banks. And I did double check that the DP3 line is connected to the correct pin, and DP0, 1, and 2 are also all connected properly. As a sanity check to make sure that those lines should be connected to the SIM sockets directly, I went to another working motherboard and it was connected in exactly the same way. So I know that that particular bodge that I added to this board is not the problem causing the system not to post. Not to mention, of course, parity memory is not required on these types of systems. And there are 3 chips on each one of these modules because it does have parity memory, but you can run the system without parity. And even according to the data sheet, the lack of parity signaling does not prevent the system from running. And really, taking a look at all the other bodge wires here, I don't think anything there has anything to do with the memory subsystem at all. The only thing that's related is that single parity line, and yet the system is still not working. Now, once this system started posting and we turned it on, we ended up with a postcode of 13 where the system had stopped. And looking at this web page right here, postcode 13 is system interrupt vectors initialized. Well, I think what's happening here is this is the one that's failing here. 64K base memory test OK. And we get that beep code and it actually displays a 13. But I think what's happening is the next test goes to start 13 and it's failing because there's no actual memory available for the system to run. And therefore we're getting that 3 long beep. And I happen to know with AMI BIOSes, those 3 long beeps is that particular memory test right there, 64 kilobytes base memory test, not okay, which generally only happens when the RAM is not installed in the board. So 100% for sure, we have a problem here in the memory subsystem area of the board. Corrosion might have made its way under the RAM sockets. That is totally possible because of course we know that there was a little bit of corrosion right here. But when looking at the board last night, once I was done filming, oh, I noticed, look at this. We have corrosion right here as well. And the thing is, that corrosion, there's no way that came from this battery leakage. My only assumption is that this board was stacked with other boards. And what happened is maybe some battery was leaking on a different motherboard and it leaked down onto the motherboard right in this spot. And maybe that has gone underneath this memory module here and damaged it. In addition, this chip right here, we peel this sticker off, appears to be a WinBond chip right here. Now, last night when I was done filming, I took a look at this chip online just to see what it might be, and it appears to be a clock chip. Strangely enough, there is literally no information about this chip on the internet, no data sheet, nothing. There is just one post I found on VCF forums with a person asking for information on this chip, and I think the general consensus is what this was just a normal clock chip, like the standard Hitachi style clock chip. So luckily I have more of those in case this is damaged, but I have to think about what my next steps are here for trying to troubleshoot this board. Now, with the board flipped over, that corrosion exists right in this area right here where I have the pointer. So it's quite possible that some of these vias here, which maybe were going under the memory sockets, are damaged. I think, I don't know, I'm kind of running out of ideas here. So I think my next step, let's break out the oscilloscope and turn the system on, actually have it run, and let's see if we can see normal activity on all of these memory sockets. The one thing about the SIM sockets that are installed on here is our 2 banks, and each of the pairs should have basically identical signaling, except for, I think, the CAS signal, the CAS signal. That would probably come from the chipset, and that selects the memory. So with these modules, we should have address lines, we should have data lines, and then we should have those other signals. Now, all of the address lines should be identical across all of these modules. The data lines between the pairs from bank 0 and 1 should be the same. So that slot and that slot, that slot and that slot, and so on. And we should see normal activity while the system is running. And then we're gonna have those CAS and RAS lines. And that's why I said that they'll be in pairs as well between these 2 SIMs. And here's a pinout for one of these 30-pin modules. So we have 5 volts, there's that CAS signal. Then we have the data lines, there should be 8 per memory modules. And then we have the address lines mixed in. And then we have a write enable signal. And then there's that parity in and out signal. And on this motherboard, and actually my other one as well, those 2 signals are just connected to each other. They kind of loop around. I like this description here, CAS P something parity. Okay. All right, we're all ready for testing. So on the SIM sockets here, towards the power connector is pin 30. So if we start on the first one here, we turn on the power, there we go, we're getting 5 volts, which you can't see because this is blocking. There we go, 5.11 volts. The next pin is the data parity signal, and I have a reset button installed. If we push it, we get some activity on there. So this is actually the data parity line that I bodged, and that signal looks completely good. Let's just compare it to the neighbor, and when I hit reset, yeah, looks basically the same. Okay, good. So we know that bodge I did is good. I'm just checking all 4 of the SIMs here, and yep, everything looks good. Okay, So next we have the CAS P line. I'm just gonna check all these look the same, and they do. Here's a RAS pin, and hitting reset, by the way. There we go. There's no RAS signal for a second, and then it comes back. So just checking all 4 of these. Ideally, I should really take the memory modules that are in this board out and double check those pins as well. In fact, I'm just gonna do that right now. So here we are on CAS P, and I'm just gonna do what I said. I'm not gonna narrate this whole thing. I'm just gonna go through and check that every SIM socket has the same visible signal on it. All right, here's pin 25, the first data line. Now remember, these aren't gonna be the same between all 4 of the sockets, right? Because there's 8 bits, 8-bit, 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 that make up the 32 bits. But we should see similar activity to this probably on all of them. I'm really looking for any kind of signals that are like floating or not there at all that could indicate that we have a break of some kind. And I'm seeing exactly the same thing on the 2 pairs, and yeah, everything looks fine. No bad signals here. All right, we are on address line 11. Now, I'm not sure this line is even used at all. I don't think it's even hooked up, judging by the lack of activity. But this signal, as far as I'm aware, is only ever used on 16 megabyte modules. And I'm not sure this motherboard actually supports 16 meg modules, so this line is probably just tied to ground, which is what we're looking at here. Okay, we're on the next address line. I'm gonna stop narrating now. I'm just gonna go through all of these and just double check that everything looks good, and I will report back if we see anything out of the ordinary. Yeah, I just found this pin and I was like, that doesn't look like it's connected to anything. Well, I just looked it up and we were on pin 9, which is ground. So that's why it looks like it's not doing anything. Okay. Okay, bad news. I'll turn the power off because the CPU is getting mighty warm. All of the signals on the SIM sockets look completely fine. I don't see anything that I wouldn't expect to see. The signal integrity looks good. Ooh, I touched the CPU there. Everything looks fine. So that's a problem because it's not able to see the memory, but yet the memory is connected. Now, there are several bus transceivers around, like LS245s. There's some over here, there's some here. And I don't really know how this motherboard is designed. Like, is the RAM and the cache memory, for instance, on a separate circuit than the ROM and the clock chip? Or is the clock chip sharing the data bus with the RAM, like those lower 8 bits? But even if it is, the lower 8 bits, they look totally fine on the RAM. So, now, I wonder if bad cache memory could somehow result in a system not working. So I just reinstalled the RAM. Let's just double check for sure that we're still getting the same postcode. Wait a second. The system is freaking posting? What the heck? I don't understand. This doesn't make any sense. How could it be working? I didn't do anything. No. I hate these kinds of problems. Let's put the video card in and we'll hook up the speaker. And we're gonna power this on and listen for a beep. No beep. But it's at postcode 85. It is absolutely 100% working right now. All right, the capture device is connected. Let's power this on. Oh, the Genoa Turbo Express version B. Seriously, what the heck is happening? I just swapped OBS over to the right profile so it's no longer squished. How is this possible? I had this memory in the board, I took it out, we did the testing, and now the system is working. So I actually have an interesting idea of a potential issue with this board. Maybe the CPU wasn't in the socket all the way, but the other thing is with this chipset here, what if we have some bad connections here on the pins? Like we have a pin that has come free or something. Let me just sort of, I don't know, run this plastic tool over them. Let's power cycle the machine here and let's see if it actually comes up still. Yeah, it's posting. All right, well, that is like a seriously unsatisfying repair there. Okay. All right, we're not out of the water yet. Let's grab a keyboard here and let's see what exactly is working and what is not working, because a bunch of those keyboard signals were bad, or, you know, they had to be replaced. All righty, power on. Okay, the keyboard didn't flash. I'm gonna say that we have no keyboard. Yeah, it's freaking working. I don't understand. I wonder why the lights didn't flash on it right here. Maybe I didn't see it. All right, well, what's in the BIOS? Okay, all the usual stuff. Let's see if the clock is working here. I'll just set something random in here. Let's just set up a floppy drive on here, even though nothing's connected. What do we have in here? Anything interesting? I don't know, all the usual stuff. RAM config, slowest. Okay, fine, whatever. AT frequency, which we can control. Video cacheable, slow CPU below 25 megahertz, disabled. Okay, not a lot of stuff in here. Hard drive utility though. Let's save this. Let's see if it's even able to save anything. So I think this chip here, the one that has the corrosion around it, is the one that is potentially problematic. All right, well, it sounds like it's trying to initialize the floppy drive. You know, I'm thinking my speaker doesn't work properly. Oh, okay, bad connection here on the postcard. Floppy drive controller failure. Well, yeah, not plugged in. 66 megahertz. CPU is configured correctly. 256K of cache. Wow, this thing is freaking working. I can't even believe it. I'm honestly shocked. I still don't get what's going on and why it's fixed itself, but it's working. So I think at this point, what I'm gonna do is I'm gonna try to take the RAM out. I'm gonna try to clean up this little bit of corrosion that's around here. I'll just use a little vinegar and a scrub brush, and I'll just scrub away the green crusties there. And there is a bunch of flux and stuff at the top here. I just need to clean that up a little bit. And I'm gonna use a hot glue gun to try to tack this stuff down and do it in a way that's not on top of these pins and things and where the holes are there for the mounting brackets. That will give this thing a little bit more longevity. And there we go, cleaned up. I put a little bit of clear nail polish over some of the, I don't know, the mess right here. It was looking not so great, but hot glue there. And if we flip it over, same thing. I have hot glue that's holding down these bodge wires, and I put a little bit of nail polish over there. I mean, these exposed traces, it doesn't really matter if those corrode more, because the bodge wires actually replaced all of them. But hopefully the motherboard still works. Oh, and I cleaned up some of the corrosion right here. So no more green and crusty. Still doesn't look super great. It seemed like the clock chip was actually working, and I actually have a battery here so we can test this out here. Now the connector here is a little worse for wear. I did tin it, although seems like since doing that I can't get this connector on. I've clipped on a CR2032 onto the connector there. I did double check that the pins are connected to ground. The one closer to the slot here is ground. That one here is the 5 volts. It goes to a little component right there. So time to install some cards here. I have an IDE card with the compact flash card on it. Gives a bit better performance than an 8-bit card. Come on, there we go. And then I have this, which is an XT IDE ROM, so that I don't have to worry about the BIOS settings, not supporting this larger, I think it's like a 2 gigabyte compact flash card. Okay, battery connected. Why don't we plug in the post card just so we can, who knows, this thing might have broken, right? Oh, sorry about that. I didn't have the microphone turned on, so you were listening to the bench camera there, but at least I have backup audio. All right, we are looking at the capture device. Will this computer still actually work? I don't know. It's posting. Oh no! Oh no, what's happening here? Okay, first of all, I had an issue before where if this was connected to certain chipsets, this particular card, it resulted in that exact problem. So let's just see if that was indeed the case. Yeah, look at that. I don't know what the deal is with this particular card. It's a WinBond card, and in certain motherboards, this card causes that weird issue. So I've seen that exact problem before, but as you can see, we booted up here. Let's set up the CMOS here, and let's make sure that the battery is actually working here. So we'll set the year to 1988 just to make sure that it's retaining the clock and the time and whatever else. As far as in here, we'll just leave this, I don't know, as is. Okay. Save those settings, and we should see the XT IDE BIOS. There it is, but of course it's not going to work because I don't have the card in there. So let's swap over to a real XT IDE so we can boot into DOS and try some games. All right, XT IDE is in. I also put in a Pico gust because why not? Might as well have a little bit of sound. And let's power it up. Should have a working system. Yes, it is posting. I still can't believe that last night it wasn't working and it just fixed itself. And here we go, we're actually booting. Do I have the speakers turned up? Should initialize the Pico gusts. I've started working on my auto exec bat on this card here to allow me to easily switch between different sound cards. No sound card configured. Okay, I just have to change this. All we have to do is rem out that. And actually I can just run it again. I don't have to reboot the computer. There it is. Oh, we're in CMS Game Blaster mode. I need to switch back to Pico or Gust mode. All right, hopefully this flashes. There it goes. It's working perfectly. And it should reboot. There it is. And now all we have to do is run auto exec again. And there it is. It is now set up as a gust, Gravis ultrasound. It's that easy to switch between ad lib or the various modes of this card. Oh, I just realized this poor CPU is baking here, so we'll just lay this heatsink on top of it there. That's all you really need to do with these old things. I've rebooted, so EMM 386 is not running. Let's run the landmark speed test. See if this thing is indeed running at 66 megahertz. Yeah, I think that's correct. 315 and 453. Very typical for a DX266. Oh, and a speed sys can't really run because I only have 4 megabytes of memory in here. Well, we're getting a performance test of 24, which I think is good. Here we are in Cubic Player. Let's see if the Gravis ultrasound card is working properly. Yes, sounds excellent. Let's see here. Perfect, perfect. This thing is freaking working. I don't know. I still can't believe it. I cannot believe it. All those bodge wires and it's fixed. Let's try Doom, which doesn't run very well on a 46. Well, I mean, it runs okay, I guess. I don't think it's fully configured for the sound card as well. We might hear sound, but no music, because I think I'm missing some patch sets for the Gravis Ultrasound MIDI support. Is this frozen? No, this is just very slow because we're running on the XT IDE, an 8-bit card, but you can see here it's still flashing the LED. And incidentally, the post codes are changing right now while the game is loading. So it must be writing to that IO port. I guess that's just part of its normal thing. And yes, we have sound effects with no music, but that has nothing to do with this motherboard. As you can see, it is absolutely running perfectly here. I don't have a mouse hooked up and it's configured right now for mouse operation. I think the WASD is configured though. Yes, I can walk around and stuff here. Not the fastest video card in the world. There we go. Whoa. I'm really not used to playing this without a mouse. But hey, it's working. This is freaking working. And look, even though the system was off for several minutes while I was getting the XT IDE and the Pico Gust, the date is still correct. So the real-time clock is freaking working. I don't know if it's keeping time perfectly. Oh, you know what? Maybe Check It can tell us that. Let's try Check It. I think if we do test and we do system board, I think this will give us some indication. Okay, so that's fully working. And let's do real-time clock, which I think is going to try to set the clock. And yeah, hey, it's freaking working. Oh, it definitely appears this motherboard is 100% operational. While I'm at it, I just dump the ROMs on this board. It's easy to do it from DOS if you have a working system. You don't have to pull the chip out or anything. The F00 and the F800, those are the system BIOS ROMs. It's like 64K on this system. The other one, the C00, that's the VGA card, and the D800 is my XT IDE, so we can ignore those. Well, there we have it. One Genoa 46 motherboard, bunch of bodge wires, and it's fully operational again. As far as the memory error we were getting when I first powered it up, I kind of have no idea what was going on. I definitely tried 2 different sets of memory in it, including this set, and it definitely had that same error every time. And incidentally, I did try 8 megabytes off camera, same problem. So I don't really know what went on because at that point I stopped. I didn't touch anything else on the motherboard. And then you saw what happened next. I did troubleshooting of the RAM sockets and then it just mysteriously fixed itself. But I let this thing run for a good number of hours, running demos and stuff, and it, fine, totally 100% stable. It is absolutely working. So I'm definitely going to upload a picture of this to the retro web along with the copy of the BIOS, so at least there's a record of this Genoa motherboard. The purpose of this video really was to demonstrate that even for a motherboard you don't have the schematics on, you don't have the data sheet, you don't really know what's going on, all you really need to do to hopefully get it working is just methodically go through all the bad traces that you can see, and you might need to remove the odd component on the board. I didn't do that in this case. And then just add these bodge wires. A little microscope like the one here that I was using is inexpensive and honestly invaluable. I wouldn't have been able to see all the damage that was on this board without that thing. So I highly recommend getting one of these. This particular one here is an Anden Star unit that they sent to me a while back, but there are several others available on Amazon and eBay and wherever else you buy your electronics goods. But it may not be expensive, but it definitely allows you to really get in there and see what's going on with the damage. This little engraving tool also came in very handy. I got this from AliExpress, I think. I don't remember the exact details on it, so I'm not really going to link to this, but all you need to do is type in engraving tool and you'll get something like this that will come up. This is good if you don't have a Dremel and you don't have access to those rubber bits and stuff. This thing actually worked perfectly. It might have been a little harsher on the motherboard than the little rubber tip on a Dremel, but to be honest, the tiny size of this allowed me to get into these very tiny little spaces here that I wouldn't have been able to do with the Dremel. So I highly recommend this for doing this type of repair. Very impressed. Anyhow, that is going to be it for this video. I hope you enjoyed the repair of this 46 motherboard, and well, I'm pretty happy to see that it's working again, because 46 motherboards, yes, there are lots and lots of them out there, but still, these things aren't just growing on trees anymore. So it's nice to know that I got another one fixed and saved from the landfill. If you like this video, I'd appreciate a thumbs up, all the usual YouTube stuff, subscribe, etc., etc. Huge thanks to my patrons. They literally make this possible now that I'm doing this full time. Their support keeps me going. I really want to give a huge shout out and a huge thank you to all the new patrons that I got when I announced last week that I'm now doing this full time. So thank you very much for the support. Really appreciate it. And yeah, I post behind the scenes videos and some kind of updates and stuff like that on the higher tier, so $4 and up tier on my Patreon. So that's really it. Screw these batteries and the damage they cause. Get them off your boards if you have any on there. And if you have a damaged board, don't be afraid to give it a try. Try to get it working. You just need some basic tools. That's going to be it. Stay healthy, stay safe. I'll see you next time. Bye.